Ooh, that's not deep. Alrighty, so today we are exploring equality to launch our equation unit. So it says, that equation up there, 85 equals 70 plus 15, states that the quantities of 85 and 70 plus 15 are equal. Is that true?
Yes.
Yes. Equal is equal. This is 85, that equals 85. So what do we have to do to maintain equality, like a balance? You know what I'm talking about in science class? You use them. So to keep it balanced, what do we have to do if we subtracted 15 from the left-hand side of the equation? Now you're going to hear math teachers say on the left-hand side, on the right-hand side, on both sides. What that means is the equal sign is the center point. So on the left-hand side refers to the left side of the equal sign. On the right-hand side means to the right of the equal sign. And on both sides means to the right and to the left. It's always based on where the equal sign is. So just in case, because I feel like we throw that term around and never explain what we're talking about. So if we subtracted 15 from the left-hand side of the equation, what would we have to do to make it balanced and equal again, to maintain the equality? What is this equal now? Is that still 85? No, what is it? 70. So how do we make that equal 70? On the right. Take 15 away from this side. Does it equal each other? Yes, we maintain equality. They're equal. All right. Ooh, darn it. We'll just do this. Oh, look at this neat turn around. Oh. How did that say?
What did you just say?
All right, now what do we have to do to maintain equality if I added 10 to the right-hand side?
You had 10 to the left.
I add 10 to the left. Now they equal each other again. Okay? What would we have to do if I wanted to divide the left-hand side by 5? Divide the whole right-hand side by 5. And what if I wanted to multiply the right side of the equation by 4? I'd have to multiply the other side by 4. So whatever you do to the one side, you have to do to the other. So this is what we know about maintaining equality. Whatever you do to one side of the equation, you must do to the other side of the equation. This is kind of like when you're scaling a fraction up or down or whatever. If I wanted this to, say it's a pizza and I know that I'm going to eat half the pizza, but, you know, there's 8 pieces. Well, how did I get from 2 to 8? Multiply by 4. So guess what? If you do it to the denominator, you have to do it to the numerator. So it's that same kind of idea, except now it's on sides of an equation. All right? Like if you're lifting weights, can you just do like 30 hammer curls on your right-hand side?
Yeah, you can do that.
What would you have to do to balance it out, though? Do 30 on the left, right? Or else you're going to look weird. Okay, you don't want to just build up one side of your thigh.
You'll be buff on one side.
There was a weird Skittles commercial, and they were like arm wrestlers, and they just had like one gigantic bicep, like arm.
Skittles commercial with the Jamaican man.
Yeah, that's weird. I can't even. That's so weird. All right, so here's this is not real, this is just a story. So in the kingdom of Monterey, the ambassadors carry diplomatic pouches. So there's the pouch, and this is your $1 gold coin. You don't have this page because it's just, there's nothing to do on it, just read. The contents of the pouches are unknown except by the ambassadors, and Ambassador Milton wants to send $1 gold coins to another country. This sounds kind of sketchy, like they want to send money over to another country, but they don't want people to know how much they're sending. So again, just a made-up story. His daughter Sarah is a mathematician. She helped him devise a plan based on equality to keep track of the number of $1 gold coins in each pouch. So in each situation in your work, each pouch contains the same number of $1 gold coins. Meaning on each side of the equation per problem. Like problem 1 and problem 3 don't have the same answer. The number of gold coins on both sides of the equality sign, or the equal sign, is the same, but some of the coins are hidden in the pouches. Because again, I don't know, they're doing some like illegal money trading, laundering, something sketchy. I'm not quite sure. So this is where your packet starts. It says, Sarah draws the following picture. Remember, she's the mathematician. Each pouch contains the same number of $1 gold coins. So you need to tell me how many gold coins are in each one of these pouches. Now, it's not that this one's 4 and this one's 7. They are all the same. Think about it. Just look at it. Give somebody a second. And then you can come up and tell me how you know. In a minute. It's not a race. Some people might need to think for a second. We have enough time to think about it. Who would like to come up and you can use the pen to show us how you reason through this? Come on up. Don't worry, there's going to be lots. There's going to be 5 different groups that can come up and.
Okay.
All that for that? Tell us how you know that.
Well, I figured out that there were 3, and there were 5 groups of rows. So I just this.
You can draw on them. You can cross out what you need to, and.
Okay, so I figured out that these 5 rows would equal these 5 rows. So you'd have to have 2 $1 coins in this to equal them.
Well, how many coins? Thank you. You're right. It is 2. Does anybody want to explain it a different way? You want to come up and show us a different way?
John, this is your time to talk.
There you go.
So we got these 4 coins right here. So if we take this, that means since they're over here, we can go ahead and cross those off.
We'll cross them off on the right then, also. There you go. There. Perfect. Did he just maintain equality? Didn't he just maintain equality by doing that?
That means we have 6 more of these left with 3 bags. So we divide 6 by 3, and we get the answer.
That's it. Very good. Very good. Yes. All right. So didn't he maintain equality? Because he says these 4 we can see 4. So you can cancel out 4 on the right. You can cancel out 4 on the left, right? Correct, I should say. So whatever you do to one side, you must do to the other side. And anything is game. Why couldn't he cross out 6 coins? There's only 4 on the right. There's not 6. Why didn't he cancel out any pouches? There's no pouches on the left. There's only pouches on the right. Whatever you do to one side, as long as you can do it to the other side of the equation, it is game. So you are going to work with partners on B through D in a minute. For each situation, find the number of gold coins in the pouch. Write down your steps so that someone else could follow your steps to find the same number of coins in a pouch. Now, I'm the math teacher, not the ELA teacher. I like bullets. So if you just want to do quick little bullets, like canceled out 4 on each side, something as simple as that. Canceled out 4 coins, 6 coins equals 3 pouches, 6 divided by 3 equals 2. That's all I'm looking for, just bullets. And then, so I'll pause the recording, you guys will work, and then when I unpause it, we will have you guys come up and explain, and we'll record that as well. Anybody who watches it gets to see your work. I love it. They are on the back, but they're asking you, how did you maintain equality, and how do you know your answer is correct? Here's the trick. You must go back to your original picture before you start crossing stuff out. So we determined there was 2 in each pouch, correct? This is how you check. How many are on the left-hand side? 10. You can see 10. What's 2 plus 2 plus 2 plus this 4? 8. Right? There's 10 over here. So 10 equals 10. So if you're saying that, say you think there's 15. 15 plus 15 plus 15, that's not going to equal what's over here. So to check your answer to make sure it's correct, you always go back to the original before you start crossing things out. Does that make sense? That's how you can check to see if your answer is correct. Who would like to come up and show us how you and a partner solve number 1? And talk to the class. You can say red. I'm going to say red or black. There you go. And the rest of you listen.
Can I go next?
So tell us what you're doing, or you can tell us, Dakota. I mean, random student.
So, on this, number 1, we had crossed out 3 coins.
Oh, that's my favorite.
He's not smart enough to know. That was funny
We had put 9 coins per bag.
Because, why could they cancel out 3 on each side? Because that's the same. Why didn't they cancel out like 15 on each side?
Because there's not 15 on the left.
Correct.
Yeah, what makes you just say?
So there's 9 coins per bag. So you were left with 27, divided amongst 3 bags. So that equals 9. Is that what everyone else got? Do you think this is correct?
Yes.
Let's check it. Just check it, guys. You have to go back to the original picture. Thank you very much. So they're saying 9 here, 9 here, 9 here. So 9 plus 9 plus 9 plus these 3. What does this equal? 27 plus 3 is 30. Equals, how many is over here?
30.
There's 30. Does 30 equal 30?
Yes.
Yes, so this is correct. That's how you check. You go back to the original.
That's pretty cool.
All right. You want to go next? Number 2?
I didn't work with him. I just work by myself.
You're good. You've got this.
See, I've worked by myself.
Here, I'll stand with you for moral
Dude, it's
support.
not a roller coaster, it's a map park.
I mean, that is a roller coaster. So what are you doing?
Crossing out.
Wow. You can cancel 4 on each side because there are 4 to be canceled on each side.
Alright, so there's 2 bags left,
On the left.
and you divide by 2.
Divide 1 by 2. How many is that? So 8 divided by 2.
It's 4. And it's 4.
I got 4 out of that. So 4, 2, 4 plus 2. What's 4 plus 2 plus 4 plus 2? Nothing. 12. 12. How many's over here? 2, 4, 6, 8, 10. What's problem? 12? No. All right. Ladies.
Kelsey going to
Number 3. Number 3.
Kelsey raised her hand. No, I didn't. So we're doing number 3?
Yes, please.
So you can mark out 2 bags every, you can mark out 2 bags over here. So you have to mark out over here. Which leaves you with 1 bag. And this is how many coins we need.
That's it. Yeah. If you can cancel out coins on each side, you can cancel out, as long as whatever you can do to one side, you can do the other. Isn't that fun? Fun trick. So let's go back and check. You always go back to the original picture. 12 plus 12 plus 12. Does that equal what's over here? 30. 36 equals 36. Does this work?
Yes.
Yes. Yeah, this is really meant to be said. Alright, number 4. Go ahead, Aubrey. So what did you do? You canceled out.
I canceled out 2 bags on this side, 2 bags on that side, and 3 coins on this side, and 3 coins on that side.
Did that maintain equality? Yes. There you go. There's how many per bag? 9. You guys agree? 9 plus 9 plus 9 plus 3 more, so this would be 27 plus 3 is 30 on the left. And then 9 plus 9 plus 12 is also 30, so it works. So we will pick up with this tomorrow.
Bye, Cameron.